Everyone, I welcome you all for the video lecture in Python programming. Python's dynamic typing simplifies coding, allowing you to focus on logic rather than explicit type declarations. Understanding these types is crucial for writing efficient and robust Python code. Numeric data types, that is the numbers in Python, includes integer, int, float, complex, complex. Whole numbers of arbitrary length, perfect for counting and discrete values, for example, 42 or 1 lakh. Numbers with decimal points offering precision up to 15 decimal places, ideal for measurements and calculations like 3.14159. And then complex numbers with a real and an imaginary part. Example 3 plus 5j, essential for advanced mathematical and engineering applications. All numeric types in Python are immutable, meaning their value cannot be changed after creation. They support standard arithmetic operations, forming the bedrock for numerical computations. Sequence data types, strings. Strings are fundamental for handling text in Python. They are an ordered sequence of Unicode characters supporting a vast range of international text. Immutability: once a string is created, its contents cannot be changed. Any operation that appears to modify a string actually creates a new one. It can be defined that is enclosed in single, double, or triple quotes, offering flexibility for multi-line strings or those containing quotes themselves. Operations supports intuitive operations like indexing, accessing individual characters, slicing, extracting substrings, concatenation, plus for joining and repetition, multiply for duplicating strings. No character type. Unlike some other languages, Python does not have a separate character type. A single character is simply a string of length 1. Sequence data types, lists and tuples. Lists are mutable and dynamic, whereas tuples are immutable and fixed. Lists are ordered collections enclosed in square brackets. They are mutable, meaning elements can be added, removed, or changed after creation. Lists can hold heterogeneous elements, making them incredibly versatile for dynamic data sets. Tuples are ordered collections enclosed in parentheses. Unlike lists, tuples are immutable, providing data integrity for fixed collections. They are often used for heterogeneous collections of data where the order matters and the content should not change. Sets are unordered collections of unique and immutable elements, ideal for tasks requiring distinct values. Uniqueness automatically handles duplicate entries, ensuring each element in the set is unique. This is particularly useful for filtering data. Operations supports mathematical set operations like union, combining sets, intersection, finding common elements, difference, elements in one set but not another, and is subset, checking if one subset is contained within another. Membership testing, highly optimized for quickly checking if an element exists within the set. Example, element in my set. Frozen set, an immutable version of a set. Once created, a frozen set cannot be modified, making it suitable for use as a dictionary key or as an element in another set. Mapping data type. which we call dictionary. The key value base. Dictionaries store data in an unordered collection of key value pairs. Defined using curly braces. Each key must be unique and immutable, while values can be of any type. Here we use curly braces. Values are accessed using their corresponding keys. Example, my dictionary name, providing very fast lookups. Common methods, important methods include get to safely retrieve values, returning none if the key does not exist, update to merge dictionaries or add or modify pairs, and pop to remove a key value pair. Real world example name is equal colon Gajan, roll number 101, city Mumbai. These are the examples of a simple student record which comes as key value pairs. Boolean and none types. Boolean we do not bool in Python represents truth values, true or false. Internally, true evaluates to 1 and false to 0. Essential for control flow and logical operations. None type. None, a special type representing the absence of a value. It's distinct from 0, false, or an empty string, often used as a placeholder or to indicate no written value from a function. Understanding these types is crucial for writing robust conditional logic and handling various states in your Python applications. Typecasting and checking. A type function helps identify the data type of any variable. For instance, type hello returns class string. This is invaluable for debugging and ensuring data type compatibility. Typecasting Python provides built-in functions like int, float, and string to convert values from one type to another. For example, int 123 within double quotes converts a string to an integer, enabling numerical operations on user input. Proper type handling is critical for preventing runtime errors and ensuring data integrity in your programs. Comprehensive summary of Python data types. Python offers a rich set of built in data types, each designed for specific data handling needs. Mastering these categories empowers you to build highly functional applications. Numeric int float complex for all numerical computations. Sequence string list tuple for all ordered collections, text and data sequences. Set and frozen set for unique unordered collections and mathematical set operations. Mapping dictionary for flexible key value pair storage and quick data retrieval. Boolean bool for logical operations and conditional statements. None type none for indicating the absence of a value. Conclusion: choose data types based on the data's nature and required operations. Leverage immutable types, strings, tuples, frozen sets for data safety and consistency. Use mutable types, list dictionary sets for flexible dynamic data structures. Always utilize built-in methods to write concise and efficient code. A deep understanding of Python's data types not only improves code readability but also significantly enhances performance and maintainability. Continuously applying these best practices in your Python development journey is important. I hope you enjoyed the today's class. Let's discuss another topic in the next class. Thank you all.